Hello to everyone. My name is Firat Akin. I am a PhD student and I am working as a research assistant at Istanbul Technical University. Today, I am going to present you our study, which is a risk-based approach to prevent unbalanced beats. My colleagues are Associate Professor Dr. Atilla Damci, Professor Dr. Polat, and Research Assistant Harun. My presentation mainly consists of 4 parts. I would like to start with introduction, then I would like to continue with the proposed unbalanced prevention model, then we will look at the case study, and finally, the last part is the conclusion. I will be happy to answer any questions via my email address, which will be seen at the final slide. Unbalanced bidding has always been a serious problem for owners in the construction industry. We defined the unbalanced bid as a bid price does not accurately reflect the contractor's profits, general overhead costs, and other indirect costs. Detection of unbalanced bids is crucial for owners because selecting an unbalanced bidder as the contractor may bring about cost overruns. There are 2 main categories of unbalanced bids. These are mathematical unbalanced bids and material unbalanced bids. We defined the mathematical unbalanced bid as the unbalanced bid is one containing lump sum or unit bid items which do not reflect reasonable actual costs plus a reasonable proportionate share of the bidder's anticipated profits, overhead costs, and other indirect costs, which he/she anticipates for the performance of the items in question. In other words, a bid is considered mathematically unbalanced if the prices of bid items are significantly overstated or understated when compared to owner's estimates or other bidders' prices. Having a mathematical unbalanced bid does not mean that it is unbalanced in a way that can increase the cost to the owner. At this point, the second type of unbalanced bid becomes the main topic of the conversation, which is materially unbalanced bid. If an owner doubts that a bid is mathematically unbalanced, the bid has to be examined in detail in order to determine whether it is also materially unbalanced. We define the material unbalanced bid as a bid is materially unbalanced if there is a reasonable doubt that award to the bidder submitting the mathematically unbalanced bid will result in the lowest ultimate cost to the government or any other owner. If the analysis of mathematically unbalanced bid reveals that it may cost more money to the owner, then it is a material unbalanced bid. Also, it should be noted that a bid can be mathematically unbalanced but not materially unbalanced. The majority of the current literature on unbalanced bidding in construction focuses on how to unbalance a bid, while only a few have investigated the ways of detecting and preventing the unbalanced bids. We know that it is important to detect and prevent an unbalanced bid to eliminate its negative effects. Most of the studies focused on how to detect unbalanced bids intending to reject them. However, encouraging owners to reach a compromise between what they want and what bidder wants can provide mutual benefits to all parties. Therefore, in this study, we proposed an approach that prevents unbalanced bids instead of directly rejecting them. It adjusts the submitted bids by using a parameter called counterbalance ratio, and it is calculated by dividing the bid price of the bidder by the adjusted bid price determined by Monte Carlo Simulation. The use of counterbalance ratio helps to counteract the effect of unacceptable unbalanced bids. The proposed approach is illustrated on an example from the literature to demonstrate the effectiveness of the proposed approach. The proposed model was developed through Visual Basic programming language integrated with Microsoft Excel. Using Visual Basic programming language helps the simulation process. And an Excel-based model was preferred because it is reliable and transparent through easy observation of the program's performance at every stage of the process. The proposed model mainly consists of 5 main steps, which are briefly explained in later slides. The first step of the proposed model is the utilization of the Monte Carlo simulation to calculate the average unit prices of the bid items. The average unit price is used to adjust the unit price of every bid item submitted by each bidder. Previous models used arithmetic mean for this purpose. However, there is a reason for using Monte Carlo simulation instead of using the arithmetic mean to calculate the average unit price of bid items, because the bid item prices may be skewed by several bidders. Therefore, using the arithmetic mean to calculate the average unit prices of bid items may not neutralize the negative effects of unbalanced bids. In addition to this, the bid item prices offered by different bidders are also estimates that increases the uncertainty inherent in the process. In order to utilize Monte Carlo simulation, the model first determines the minimum, most likely, and maximum values for each bid item to define a triangular distribution. As it is seen in equation 1 and 2, the minimum and maximum unit prices offered by bidders represent the minimum and maximum values for the triangular distribution respectively. The average unit price of all bidders for each bid item is defined as the most likely estimate, as it is seen in the equation 3. In the second step, the Monte Carlo simulation generates random bid item prices based on the designed range of values and triangular distribution. This process is repeated for the number of iterations determined by the user. Thereafter, the Monte Carlo simulation provides a distribution of bid item prices. The arithmetic mean of the values of the bid item prices in this distribution is calculated in order to be used in the computation of the counterbalance ratio, as it is seen in the equation 4. The proposed model intends to stop excessive unbalancing by keeping it within the reasonable limits. Therefore, it uses a counterbalance ratio to adjust the bid item prices submitted by each bidder. In the third step, in order to compute the counterbalance ratio, the total bid price of each bidder is divided by the adjusted bid price calculated using the average unit prices of each bid item obtained as a result of Monte Carlo simulation. In the fifth equation, we are multiplying the unit prices submitted by the bidder N for the item N with the quantity of item N. Then we are taking the sum of all item prices. In the sixth equation, we are multiplying the unit price derived by the Monte Carlo simulation for item N with the quantity of item N. Then we are taking the sum of all item prices again. In the equation 7, we are dividing the total bid price submitted by bidders with the total bid price derived by using the unit prices, which is also derived from Monte Carlo simulation. Eventually, we obtain a counterbalance ratio for each bidder. In the fourth step, the bid item prices submitted by the bidders are multiplied by the counterbalance ratio to compute the adjusted bid item prices. Thus, the proposed model neutralizes negative impacts of manipulated bid items. In other words, the proposed model rebalances all the bids submitted by the bidders. In the last step, the total bid price submitted by a bidder is recalculated by using the adjusted bid item prices. The proposed model ensures that the total bid price of a bidder remains unchanged after adjusting the bid item prices. Thus, the nature of the competitive bidding is preserved. Most of the previous unbalanced bid detection models reject unbalanced bids without considering the adjustment of bid item prices. However, the proposed model in this study adjusts the bid item prices instead of rejecting unbalanced bids. Thus, it protects the interest of owners. In addition, the proposed model preserves the total bid prices offered by a bidder to provide a fair competition environment. The illustration of the proposed model can be best demonstrated by an example. An example project from the literature is used for this purpose. The example project consists of 17 bid items. 5 bidders submitted bid offers for the project for the illustrative example. The information on the estimated quantity and unit prices offered by the bidders for each bid item is presented in Table 1. Bidder 1 submitted the lowest total bid price. If one reviews the unit prices presented in Table 1, one will see that Bidder 1 submitted extremely low unit prices for bid items 1, 7, and 13, when compared to the unit prices of other bidders. On the other hand, Bidder 1 submitted extremely high unit prices for bid items 4 and 5, when we compared them to the unit prices of other bidders. The discrepancy generates a reasonable doubt that award to the Bidder 1 will result in the lowest legitimate cost to the owner. In order to investigate this further, the steps explained in the previous section are followed to run Monte Carlo simulation for 5,000 iterations. In order to calculate the average price of the bid items, random bid item prices were generated at each iteration using minimum, most likely, and maximum values. The adjusted bid price is calculated using the average price of the bid items obtained from Monte Carlo simulation and the quantities estimated by the owner for the bid items. After calculating the adjusted bid price, it is divided by the bid price of each bidder to compute the counterbalance ratio for each bidder. The counterbalance ratios and adjusted bid item prices of each bidder are presented in Table 2. The total bid price of each bidder is preserved unchanged even if the bid item prices are adjusted by counterbalance ratio, as it can be seen in Table 2. The total bid prices are based on the estimated quantities. However, the actual quantities rarely match them. Therefore, the cost of example project is also determined by multiplying the submitted bid item prices with the actual quantities identified during the construction, as it can be seen in Table 3. Assuming that the lowest bidder, for this case it is Bidder 1 of course, is awarded, the findings reveal that the owner ends up paying $700,000 more than the submitted bid. It also should be noted that the lowest bidder becomes the second lowest bid when the actual quantities are considered. After adjusting the unit prices by using the counterbalance ratio, the owner saves more than $13,000 when comparing the amount found by multiplying the actual quantities with the unadjusted bid item price, as it can be seen in Table 4. It should also be noted that after recalculating the bids using the actual quantities but the adjusted unit price proposed by the bidders, the original lowest bidder remains the lowest bidder, which is also quite important. Let me conclude our study. The detection and prevention of unbalanced bids is crucial for both owners and contractors to maintain a competitive environment. Even though owners tend to reject unbalanced bids, reaching a compromise between what owner wants and what bidders want can provide mutual benefits. For this purpose, an unbalanced bidding prevention model is presented in this study. The proposed model provides a procedure to prevent unbalanced bidding by rebalancing the bids rather than rejecting them. A parameter called counterbalance ratio is used to adjust the submitted bids. The counterbalance ratio is computed by dividing the submitted bid price by the adjusted bid price determined by the Monte Carlo simulation. The use of counterbalance ratio does not change the total bid price submitted by the bidders. but it alters the bid item prices. An example project from the literature is used to demonstrate the application of the proposed model. Indeed, the findings reveal that the model prevents unbalanced bids while keeping the original lowest bidder as the lowest bidder. It is also anticipated that the proposed approach will deter bidders from unbalancing their bids. However, the proposed model has a limitation as it does not consider the time value of the money. In addition, comparing the developed unbalanced bidding prevention model with alternative models can be explored in the future research. Thank you all for listening. If you have any question, please do not hesitate to reach me via my contact information. Have a nice day.